to try to first fix the actual in the clear Wi-Fi network. And once we've got that stabilized, hopefully in a couple hours we'll bring up the WaveSec network inside of that. Any questions? Am I making sense or am I just about to work? I like the thumb. So I'm going to trust Paul and fearless leader John here to introduce you to the WaveSec stuff.
So I'm John Gilmore, and I was late. I apologize.
It's better than being the late John Gilmore late.
Okay, so I'll just continue with the slides now. If anybody has questions, just feel free to interrupt me and ask them quick before I end. So first a real brief overview of what's WaveSec. Basically, you can see it as a two-part system. The first part actually makes sure that you're talking privately to one other entity on the other end. This ensures that you're private, but however, you don't know who it is. So it could actually be a man in the middle. The only thing you know, using a different element key exchange, that you're talking to one person and there's no eavesdropper except for that one person listening to the connection. So once you've done that part, you still need to verify who you're actually talking to. That's part. The second part of the IPsec negotiation. Then they exchange IDs, tell you who they are, and they basically try to check out if you're really the guy who claims to be your man in the middle. Obviously, for that to work, you need an external reference. If two parties talk to each other and you've never talked to each other before, then how do I know that you're really the person you're saying? So I need like a third reference that can verify that you are you. That's what we'll be meeting later on for the stuff. So what happens? Both parties agree on who they are. They check it out. They check on the encryption method, ciphers used, the strength used, and for the IPsec part in the end, they also put policies in place to see. To say which IP numbers are actually allowed to go over this encrypted connection. So that's in essence what IPsec does compared to normal IP. So many years ago, John decided that it would be a really good thing to have IPsec basically the default out there instead of doing all these things in here and then protecting your web server or protecting your login to your web server. We should just have this for default on all the connections. And he started a free-form project which was focusing on something that we call opportunistic encryption, which basically means, as the index says, try to talk to everybody encrypted even if you've never met them before and have no clue who they are. And still you want to talk encrypted because it still means that nobody else can sniff you, nobody else can be in the middle and listen to it. And if they still don't listen to you, we have to do an active attack instead of just eavesdropping, which turns it from basically to a crime if you do this lawfully. So apart from the one-to-one host encryption, which is of course what we would prefer to see, every single host talking to every single host with crypto, that's not going to be realistic for all situations. So there's a separate way where also one machine can do crypto for, say, a subnet of other machines. For instance, if you've got a lot of Windows machines, a server somewhere, you could use one machine that actually does opportunistic encryption to protect all those servers, do all the crypto for them, and then only the connection from that data machine to the Windows servers will be clear, which should be your trusted network probably, so that will be okay. It still means that nobody can eavesdrop even on your Windows farm. So, how do we do this? The only thing we know when we talk to another IP address out there is actually its IP address. The only thing that's bound to that is the DNS. So we actually put stuff into the DNS to see what everybody can do. So there's a special TXT record that you put in if you can do this opportunistic encryption trick. You can see here that there's an example record. It's called bofh.xdnet.nl. That's my desktop at home. You can see its IP address, which is 193.110.157.17. And it has a TXT record in the DNS in the reverse zone that says IPsec server, my IP address, and then the crypto key that it's using to run IPsec. So basically, anybody who has this TXT record can then use this to initiate an IPsec tunnel to my machine at home and talk security to me. The DHCP server and clients support things like DNS dynamic updates. You can actually change it on the fly if your DNS changes. And there's lots of things you can do to keep these records up to date. The DNS is also a very good way to distribute this key information because we don't want one big key database out there that somebody could compromise or abuse. This way, everybody is responsible for their own keys and their own DNS space. So this is all very well if you actually control your reverse. Not everybody controls their reverse DNS mapping. So even though you get an IP number, you do not control what the IP number is called in DNS. Now we also found a way around this problem. If at least one of the two PCs talking to each other actually have the key in the reverse, then if one has it, the other no longer needs it. Because what it will do, it will just send its fully qualified domain name as a sort of an identifier in the tunnel negotiation, and then the other end will just look in the forward DNS. And since many people have their own domains, they usually do control a forward somewhere, or you can use DIN DNS or whatever today's free DNS shell.
Let's find out what these guys want to find out about. Okay, can we ask you a couple of questions? Why are you here? What do you want to learn from us? No. Yeah, you can shout if it's short. So you want to find out just how to set it up and make it work? You don't want all the grungy technical details behind it? Or do you actually care like how the protocols work and all that?
I'm interested, but essentially it's the same as then I can go right here with the
For now, the openness encryption extensions is a limit on the thing, yes, but we're working on something else.
We'd be happy to have other people implement it. The protocol is described in an RFC for an internet traffic.
What needs the only response or only
No, I'll get to that. But basically,
Could you repeat the question?
sorry, yes, the question was does it only work with pre-response specific stuff, but also the other IPsec stuff that's out there for Linux. And yes, it works on both, but I'll get back to that in detail later.
Okay, I'm here to find out how to use encryption and especially authentication in wireless networks, because I run a small village area network, and we are searching for a way to let only those into the network that we want to be there. And that's why I'm here to look at the encryption.
Okay, I can explain you later on a bit. I'll tell you how you can actually use the stuff we're using to actually do that and live in it.
Right. So it sounds like what we should do is skip forward to the how do you set this up here at the conference on your laptop part, which, as Stu explained, won't work for you yet. You can get all the software downloaded and ready, and when we get the machines in the dock running properly, then you can just turn it on and it'll work.
Okay, well, then I can just race through that some of it and then just go. Open Office is not the best piece of software out there.
Yeah. Page up.
Well, I'll say that to go briefly through it, because if you know the DNS records are big, then at least you can debug things if it doesn't work out. So let me just really quickly go through it.
Well, why don't you skip some slides while I sort of talk about how the WaveSec here. You want? Yeah. Okay. And you can sort of skip forward to that part of the problem. So normally when you're running opportunistic encryption, you've got to put DNS records into your domain name. And that doesn't work if you just show up somewhere and you get on a wireless network and you plug in. So what the WaveSec step does is automates that process. That when your laptop comes up on the net and says, "Hi, I need an IP address, DHCP, where are you?" The DHCP server has been jiggered so that it will, besides assigning you an IP address, it will also send you back a key record. It'll put a key record into the domain name system and will send you back the corresponding key.
You send, if you've configured everything for WaveSec, what you do is in your initial DHCP request, instead of sending one packet, that you send two packets, and one of them actually contains the key that you're using. Then the DHCP server assigns you an IP address, and then already puts that key into its reverse because it just knew what IP address it gave you. So your key record's already set up. And then in its answer to you, where it tells you what IP address to use, it also gives you the key of the server. And then, the IP address of the server. And then with the IP address, and you configure your own end, you look up the key record in DNS of the WaveSec server, and then you have all the information you need to set up one of these encryption tunnels.
Okay, so for making your laptop run securely here, what you need is to have FreeSwan installed on your, first you need to be running some version of Linux. Install FreeSwan on it, and install the modified version of the DHCP client. And once that step is done, when you turn it on, then and reconnect to the network, then it will automatically send over your DHCP client will send your key over, it will get put in the domain name system, and you'll get hooked up. And that's described in the slide toward the end of the talk.
Well, okay. So if you want to install FreeSwan, also you can just get the binaries from the distributions, except for Red Hat, for which we make binaries you can also use, or you can install from source hardware and you can binaries. Download things. You can read the README if you want to really build it. Basically, you have to first make sure that you actually have a kernel that already builds without FreeSwan, and just install FreeSwan by uninstaring it and type make alt go. It will reuse your kernel configuration, build the right stuff, install the modules, and off you go. For the 2.5 kernel, if people really want to experiment with it, it's still very unstable. But with the alternative IPsec stack that the Red Hat people have been making, things should work. Just make sure that you use the latest development version of FreeSwan, and make sure you use the very latest 2.5 or 2.6 kernel. And then still you will run into problems. So if you just want to experiment with some somewhat stable WaveSec, use FreeSwan. If you just insist on running on 2.5 kernel, then you can try, but you'll run into some weird problems. First of all, of course, if you just install it yourself, you will need your cryptographic key. Normally, if you install from binaries, this is all stuff that's been done for you. If you install from source, you need to do something manually. First, you need to create your host key. You can see here with the IPsec host key command. Then the proper DNS records you don't need unless you're signed up for generic OE to all of those on the internet, and only create these TXT records and put them in your DNS. But if you're just doing the WaveSec, then you don't need this because the HTTP client will send the key. This is also, if you want to do a general OE, so if you want to do opportunistic encryption, not just the WaveSec, but for all hosts, this is the connection you need to define. You can look up at the slides that are online, so you can find them. This is the WaveSec server part, which if you really want to set up the WaveSec server, I guess you should talk to us. This is where the client part comes. So you need to get the patch for these clients, which you can get from wavesec.org. It's expected to go into the next version of DHCP. Unfortunately, the maintainer of it has been rather slow. He has the patch, it's in his queue, but he hasn't released a new version since about 6 months. If you're running old Red Hat, then the old Red Hat still uses the DHCP CD client, which does not support all the extra things we've added, so you need to use the DH client from ISC. We made a patch for the old script for Red Hat 7 and 8. If you use Red Hat 9, you can just install our patch version of DH client, and then Red Hat automatically picks it up. And if you want to play safe, then you can remove the RPM for DHCP CD. And then if you want to implement IPsec show host key --DH client and append it to a file cdh-client.conf, then you get all the parameters ready to use for the WaveSec part. I'll show it to you in a bit.
Okay. Now, if you install all this stuff and you get yourself onto a network that doesn't support WaveSec, your DHCP will just give you an IP address and it'll all work fine. But if you get onto a network that has a WaveSec server, then you'll get encryption over the air in addition to just getting an IP address. So it's safe to install this stuff.
Yes, and also the way the WaveSec server itself works is that it's just another DHCP server in your network, and it only replies when it actually sees clients that send the key and say, I want to do WaveSec. So if you install this in your network, you're guaranteed not to break your regular DHCP because it will just never answer to the normal clients. So normal clients will not see any difference. Only the WaveSec people might get broken if your stuff breaks, but you will not break anybody else. So it's a really nice drop-in. You just drop it in, it doesn't break anything else, and your network administrator shouldn't get too scary about having another DHCP server in the network. It's harmless. So for FreeBSD and accounting clients in general, it also works with a lot of manual work. If you look at the WaveSec site, then you can see some people who've done it. So feel free to look there to actually also use this. And if you got any manuals for how to do this on various BSDs, then feel free to send us your manual. Of course, it would be very nice if you could make this work with Windows. Unfortunately, as always, Microsoft would like to use their own stuff. So basically, they're doing a sort of variation of opportunistic encryption, which means that you ask their LDAP server for a key and you use that. Which of course defeats the whole point, because we want to talk to everybody in the world encrypted and not just to Microsoft certified LDAP servers. So they're not going to do this DNS, keys in DNS thing. Some people are thinking of doing something with X59 certificates, so you can just find the WaveSec server, redirect port 80, find it, download a certificate, and set up a connection that way. But it hasn't been really thought out yet. Some of the other clients, SSH, Sentinel, should be able to work with it just fine, because they just put in their own IPsec stack on the Windows machine. This is general testing. This is in theory we also support DNSSEC. So if you're doing OE out there, and of course you put your keys in the DNS and everybody can spoof the DNS. Of course we support DNSSEC. Untappable XDNet analysis. The first circle actually has some DNSSEC awareness on it. It's also in the latest released version of FreeSwan. In 2 days I will give a talk about DNSSEC and how to actually secure your own domains using it, and then of course you can actually rely on the keys not being changed to somebody else's key by DNS spoofing. These are some test sites for the generic OE.
Yeah, so back to that. So one of the problems with opportunistic encryption is when it's working, it's invisible. Right? Your packets are going through, you're browsing the web, you're doing email and all that, and it looks just the same whether you're in plain text or encrypted. So how do you tell whether it's working? Well, in our test setups, we use 3 different machines. We put a guy in the middle and we listen on the wire and all that. But such a pain in the ass when you're just carrying your laptop around. So we set up some web servers around the net that you can just go to. Go back. Yeah. Anyway, we set up some web servers you can go to. oetest.freeswan.org will put up a screen, or give you a link you can click that basically says, tell me whether I'm running encrypted to you or not. And we put the magic out there for it to look. So once you think you have it set up, just try our connection to oetest.freeswan.org. Well, you can try it now. If it doesn't tell you you're running in the clear, then you're way ahead.
Actually, that's not entirely true, because if you're running WaveSec, it will still tell you you're running the clear while your last mile is actually encrypted. Okay, I guess I can show the configuration on my laptop, to give you an idea of what the extra stuff is we put in. Yeah. So this is what's been generated if you use the WaveSec show host key command -/-dx-kind. You see it puts my fully qualified domain name in there, some old stuff in there, which you can come on. Then you see option OE key, which basically says, I want to know about an option OE key, because I want to send and receive it. And then you see the extra option send OE key equals, and then my key. And then you can see normally the DHCP client actually asks for these attributes per default. So it asks for subnet map, for broadcast routers, DNS servers. So we add one that says ask for OE gateways. Now our client is actually saying, please give me an OE gateway. Then there's the keyword prefer OE gateway, which means that if multiple DHCP servers answer our query, if there's one that has OE, we prefer that, because we don't want to connect to the regular DHCP server. One other new entry is the timeout. Normally DH client immediately once it gets a release from the first DHCP server, immediately takes it and goes with it. Of course, we want to wait a little bit to get more offers and see if there's anyone who can do OE. So the timeout is actually important. Also, if you want to do, for instance, if you're running your own DNSSEC name server on your laptop, then you actually want to do something as prepend domain name servers, so that you can actually check all the keys that you're getting and that they're put in DNS and check if they match your real domain name content. So that's where the prepend statement can come in handy. And then at the end, actually run something called DHCP time exit hooks. Once it gets that number, that's where you can put all your script stuff. It's a bit confusing on some versions. You actually need to enable the script on others. Actually, it actually does it automatically. So only enable this line if you actually don't see anything happening, because if you enable this, you might also run it twice. Oh, for Red Hat, you need to make sure that there's a DH client-eth0.com or whatever your network interface is as a soft link to dhclient.com, because the standard DH client uses first and Red Hat uses the second. This is insert exit hooks. It checks, do I get a new IP number? Then run the script called IP, which it gets from the file boot funds. And then it restarts IPsec, because actually we're going to stop it, start it, and then inject the new rule. We need to stop and start FreeSwan at this point, because normally the DH client means that an interface got added to your system. And currently we do not support dynamic interfaces very well. Hopefully that will get fixed. So then the real work is done in boot funds. where you can see that if we get the option OE gateway, then you're going to do a lot of things, and then you're going to see some things that nobody should see. Actually, we're just going to manually open the hood of the car and basically show some commands and that we tell you not to use on the website because it's not documented internally. So, yeah. And then this last one actually sets up the WaveSec connection. Now I can actually try and see if by now, if Daniel who's going to the north actually set it up without working.
You're going to try it?
Sure.
Real time?
Sure, I'll just try it and see. So, and then you see one other problem. Standard DHCP puts the lease file in var lib, and actually that's standard correct, at least ISC standard put it in state. Kill our DH client. Sadly, DH client cannot tell if it's already running for the interface, so can actually run into that. Okay, so I have killed my old lease files, because if I don't remove my old lease files, my DH client will actually request the old IP number back and see, hey, I actually want to renew this lease, can I get the old one back? And since we're actually giving you a whole separate range of IP addresses for this, then I wouldn't get WaveSec because I would just get an offer from the regular DHCP server. Okay, so let's run it. So now it's sending a DHCP request with our key out there. It gets an offer from what looks like the regular DHCP server from CCC. We don't see a second offer, so obviously there's no WaveSec server at this moment listening. So we'll just do normal stuff now. We'll wait for a while. And now it restarts my IPsec anyway, because if you do normal operations encryption instead of just the WaveSec part, then this is another interesting bug. Sometimes on my laptop the DHCP server actually doesn't give me the default route, or my computer forgets that it gets a default route. It's actually interesting. Actually, I remember why this happened. The freeze one was still running when I was running this client. Let's try one more time. Actually got the old lease. You can see renewal and so did a renewal, so they actually used the old one because they were still partially available. So the WaveSec is probably still not up. I can check. This is an internal feed to see actually. We're keeping track of which connections, when using OE, which connections are actually encrypted or not. You can see that actually that we're tracking all the packets so that we can see whether we or not we can encrypt them to the destination. You see two hold addresses, which are packets that I'm sending that have been taken and set aside while trying to negotiate an opportunist encryption tunnel. By now, if I do it again, I should get either a pass route when it says it fails to get encryption going, or should get a tunnel. No, there we go. We got pass routes now. So those boxes did not support openness encryption, so it took a while to figure out. Do some DNS request and timeout. But for instance, if I now go to the freeze-on web server, you'll see it takes a there we go, it's actually fairly fast. If I now take a look again, we can see that I actually have a tunnel going. You can see the freeze-on web server is 193.110.157.9. On the left you see my IP memo, on the right you see the tunnel, and you can actually see that the security gateway is not the same. Machine is not .9, but security gateway is actually .77. So I'm having a tunnel from my laptop to .77, and that machine decrypts it and then sends it on to .9.
Now, before he scrolled the screen, look up towards the top where he did the ping. That first ping came back in 2179 milliseconds. It took it about 2 seconds on the very first packet. To grab that packet, go do a DNS lookup for www.priest1.org's reverse entry, find that there was a key, talk to the server at the other end, set up the Diffie Hellman, do the RSA, and establish the tunnel, and then send the packet and get it back. 2 seconds.
So now I'm actually try
And then after that, of course, a tenth of a second, 20th of a second, once the tunnel is set up.
and well, here just to so I'll run TCP down here. Oops. And if I then from again, in the server, that's strange because it already did it before.
Mark is having trouble.
Okay, I think the wireless network has some more problems.
I think we lost our wireless power.
Yeah, it's okay. Maybe someone walked into the base station. No, it still seems to be on whoever claims to be Camp Tower too. Good connection. Okay. Let's see if it's the strongest to it. That's good. This. Actually, I think I lost my default gateway because otherwise I should see packets already.
Yeah. Say you lost all your Ethernet. Well, it's a good thing we decided to do a live demo here. Any questions?
Okay, well, later on when the network works, go to www.wavesec.org. You'll see all the files that you need to download. You can try it yourself, or you can grab me and I'll come look at your laptop and both work on it.
Remember to put something on Camp Wiki.
Sure, okay, if it's up,
That's a good idea.
sure, yes, if it's up, I'll actually put it on the wiki and say where
Something's
it's
on the wiki right away, so we go on the right page.
I'll put something very red on the wiki page, and if it works, I'll put it very, make it very green.
A little question about the performance of FreeSwarm. Is it possible to connect, let's say, 500 PCs over a FreeSwarm connection to build a tunnel? You see, I don't mean if you have, for instance, two private networks and you want to communicate, or in the grid computing environment and so on, or distributed computing, and you want to establish a virtual tunnel. And security is a nice feature, but not the most important part. The access to the resource, another virtual domain or private domain. Is it possible to establish such, not for the private or one PC solution or more for 500 PCs? Is it possible to do this over freespawn?
Yes. I'm not exactly sure what the question is. If you're
For instance,
asking,
you have a 100 Mbit connection, and you want to connect two private networks. Each private network has around 300 or 500 PCs.
Yes, there are people running with several hundreds of tunnels per machine.
And it's working with a fast internet connection.
but yeah, it works fine.
Yeah.
Processors keep getting faster than we can find ways to burn them off. There's a tiny fraction of the market, like Google or somebody like that, that might need to go to using hardware encryption or something. But everybody else, you can totally max out a T1 line on like a 386. If you're running something faster than a T1 or an E1, use a Pentium.
If there's a BSD coder out there that can be this encryption hooks to go into BSD, please talk to me. You'll also have to convince me this provost text into it.
All right, you're excused. You're dismissed. Get out of here.